Good morning, students. Welcome to the software engineering course under Markout. This course will help you understand key concepts and clear your doubts regarding this subject. Stay engaged as we will be covering essential topics step by step. We will also bring another part soon to deepen your understanding. Let's begin.
Good morning, everyone. It is an honor to stand before you today and talk about extreme programming, or XP, one of the most widely used agile software development methodologies. As software developers, engineers, and project managers, we all understand the constant challenge of balancing speed, quality, and flexibility in our projects. XP was designed precisely for this purpose, to help small to medium-sized teams develop software efficiently in environments where requirements are vague or change rapidly. At its core, XP is built around coding as the primary activity throughout the software development lifecycle. Unlike traditional methodologies where extensive documentation precedes coding, XP allows code to take center stage. Why? Because code is the most direct and unambiguous form of communication among team members. Rather than relying on complex specifications, XP encourages defining the lifecycle and behavior of complex objects directly through test cases written in code. Throughout this presentation, we will explore XP in detail, its practices, principles, and how it differs from traditional methodologies. By the end, I hope you will have a deeper understanding of how XP can be leveraged to build high-quality software in dynamic environments. Let's get started. XP is built around a set of core practices that ensure efficiency, adaptability, and collaboration. Let's discuss the first 6 practices. Planning game. The planning game is an essential practice that helps determine the scope of the next release. It brings together business stakeholders and developers to combine business priorities with technical estimates. This ensures that the most valuable features are built first, maximizing impact. Small releases. Instead of waiting for months to deploy a fully built system, XP promotes small, frequent releases. This helps in getting early feedback, reducing risk, and improving adaptability. Metaphor. A shared metaphor or story is created to guide development. This ensures that all stakeholders, both technical and non-technical, have a common understanding of the system's workings. Simple design. Simplicity is a fundamental principle of XP. The system should be designed as simply as possible, with any unnecessary complexity removed at the earliest opportunity. Testing. In XP, testing is a continuous process. Developers write unit tests, and customers provide tests for features to ensure that the software behaves as expected. Refactoring. Code is continuously refined and restructured to remove duplication, improve readability, and ensure maintainability, all without changing functionality. These practices, when implemented together, ensure that teams can rapidly develop high-quality software while being responsive to change. Let's now look at the remaining 6 XP practices. Pair programming. All production code is written by 2 developers working together at a single machine. This fosters knowledge sharing, reduces errors, and improves code quality. Collective ownership. Anyone in the team can modify any part of the code. This eliminates bottlenecks and ensures that knowledge is not siloed within specific individuals. Continuous integration. Developers integrate and build the system multiple times a day. ensuring that changes do not introduce defects. 40-hour work week, XP promotes. Sustainable work hours, ensuring that developers remain productive without burnout. On-site. Customer. A customer representative is part of the development team, providing immediate feedback and clarifying requirements in real time. Coding standards. All team members follow a shared coding style, emphasizing readability and maintainability. By following these practices, XP fosters an environment where collaboration, simplicity, and quality take precedence. XP takes common-sense software engineering principles and pushes them to the extreme. 4. Example. Code reviews are good. Then let's review code all the time through pair programming. Testing is good. Then let's test continuously, ensuring that every line of code is covered. Simplicity is good. Then let's always implement the simplest solution that works. Design is crucial. Then let's refactor continuously to improve the architecture. Integration testing is valuable. Then let's integrate and test multiple times a day. Short iterations improve adaptability. Then let's make iterations as short as a few hours instead of weeks. This extremity makes XP one of the most effective agile methodologies for teams that need to move fast and adapt to changing requirements. Some of the important links are here. Please go through these. An important aspect of the structured evolutionary prototyping model, when to use it. While this model offers flexibility and iterative development, it is not always the right choice for every project. Understanding when to apply it effectively can lead to better software development. Outcomes. Handling unstable or unclear requirements. One of the best use cases for evolutionary prototyping is when requirements are unstable or need clarification. In many projects, especially at the beginning, stakeholders may struggle to define exact needs. Prototyping allows developers to build a preliminary version and refine requirements through user feedback. Complementing the waterfall model. This model is particularly useful during the requirements clarification stage of a waterfall model. Instead of moving forward with incomplete or vague requirements, evolutionary prototyping can help validate expectations before committing to full-scale development. Developing user interfaces. Another ideal scenario is when the project involves developing user interfaces. UI design is highly interactive and benefits from continuous user feedback. Prototyping ensures that usability, aesthetics, and functionality are refined before final implementation. Short-lived demonstrations. Prototyping is also effective for short-lived demonstrations. If you need to showcase a concept, test a new idea, or present a working model for approval, a prototype provides a functional representation without the need for full-scale development. New and original development. When working on new, original development, evolutionary prototyping helps navigate uncertainties and allows teams to explore different possibilities before finalizing the design and architecture. Object-oriented analysis and design. Finally, this model is useful for the analysis and design portions of object-oriented development. Since object-oriented programming relies on modular and iterative design, prototyping can help refine class structures, relationships, and interactions before committing to the full system. Conclusion. In summary, the structured Evolutionary prototyping model is highly effective when dealing with unclear requirements. Developing user interfaces, presenting short-term demonstrations, or working on innovative projects. It also serves as a valuable tool during the early stages of structured development. Methodologies like waterfall and object-oriented programming. By strategically applying this model, where it fits best, teams can create better software with improved user satisfaction.